Hello guys, first of all thank you for watching this video. Today we are going to see or learn about general purpose and embedded systems boot flow. Hope you are doing well and hope you will learn more about this general purpose and embedded systems by the end of the video. So first we are going to see about what is boot flow. So boot flow is nothing but a sequence of steps of a computer system that goes through when it is powered on or on restart. So whenever we are going to power on our system computer, so the steps which will happen till the power on state until the login prompt appear on the screen is called as boot flow. So this process will be taken in both the general purpose systems and embedded systems. So first of all, we need to learn the difference between general purpose systems and embedded systems. Let us see what is a general purpose system. General purpose system is nothing but our general desktop computer, which is designed to perform a wide range of tasks rather than being specialized for a specific function. So as you all know, our computers are designed to perform wide range of tasks at a time. It will perform numerous number of tasks. While we are performing a single task, alongside of that it will perform many tasks. So these systems are capable of executing different type of applications and tasks at a time, and they are capable to handle varying workloads. They are able to work with different softwares, hardwares, and different types of networks. So some of the examples of this general purpose systems are desktops, laptops, etc. And moving to the embedded system, so it's a specialized computing system. So it is dedicated to perform some specific tasks or functions within a large system. Means it's a small system which is designed to perform only a dedicated task and which is used to build a large system which is performing a numerous number of tasks at a time. So unlike general purpose systems which are running a variety of software applications, embedded systems are designed to execute only particular tasks efficiently and reliably. So coming to the examples of embedded systems, let us consider calculator is an embedded systems. The main task of the calculator is to give the result of the numbers that we had entered, and televisions, cameras, Wi-Fi routers, ATM machines, microwave ovens, everything is an embedded system which we are used to build a large systems which are general purpose systems. So coming to the boot flow of general purpose system, it includes mainly 7 steps. The first step is called as power on self test. In simplest form it is called as post. Second one is called as bootstrap loader. Third one, bootloader. Fourth one is called as kernel loading, or in the fourth stage kernel loading will happen, and in the fifth stage kernel initialization will happen, and in sixth one init or system function will start running, and on the seventh stage user login screen will appear. Moving to the first stage, which is power on self test. So this is the main or first program which is executed after the power is given to our system. So in the older systems we call this one as BIOS, and in the newer system we call this one as UEFI. BIOS is a piece of code which is exist on the on-chip ROM inside a computer inbuilt. So this is unchangeable. So when the computer is powered on, the BIOS or the piece of code which is stored in this BIOS chip will perform a test to ensure every hardware component like CPU, memory and storage are functioning correctly. If it finds any default or defect in that devices, it will give an indication with the beep sound. So this is BIOS. Moving to the next part, which is the difference between BIOS and UEFI. So what is BIOS and what is UEFI? BIOS and UEFI basically both serves the same operation, but BIOS is the one which is introduced by IBM in early 1980s. But now, instead of BIOS, every system is coming with UEFI, which is called as Unified Extensible Firmware Interface. So it came as a successor of BIOS, and it is introduced by a group of technology companies including Intel. You see, in our older systems, we can see the BIOS or the Windows Boot Manager is a text-based low resolution interface. We cannot get any graphical interface in our old systems while we are doing any BIOS related changes. But nowadays, since we are using UEFI systems, it supports GUI and mouse navigation. In our older systems, it doesn't support mouse interaction, but we need to use our keyboard to select or to change options. So what's the drawback of BIOS is it can't boot from the drives or from the hard drives which is larger than 2.2 TB because of this MBR partitioning scheme, and it operates only in 16-bit mode. But coming to the UEFI, it can boot from drives which is larger than 2.2 TB and it operates in 32-bit and 62-bit modes. Hope you understand the differences between BIOS and UEFI. Coming to the next step, which is bootstrap loader. So after the power on self-test is performed, the BIOS in the older systems or the UEFI in the newer systems locates a small code which is called as bootstrap loader. This bootstrap loader is responsible for loading the operating system from the boot media. This loader is usually stored in the first sector of bootable storage device, known as master boot record or GUID partitioning table, GPT. Bootable storage device is nothing but the hard drive where we can store hard drive or SSD or pen drive where we can store our operating system. So after locating the operating system, this bootstrap loader, what will it do is this loads the bootloader into memory. It will find a bootloader from the hard disk or the SSD and it will load the bootloader into the main memory, and main memory starts execution of that bootloader. And after the execution of bootloader, what the bootloader will do is the bootloader finds the operating system kernel from the bootable media like HDD or SSD, and it starts loading that kernel into the RAM. So the newer version UEFIs will use GRUB as a bootloader. The full form of GRUB is nothing but ZR and Unified Bootloader. So Windows systems will use Windows Boot Manager, whereas Linux systems is using GRUB, which is called as ZR and Unified Bootloader. So next to the bootloader, so after loading bootloader into the main memory and after execution of bootloader, the kernel will load into the main memory by the bootloader, and the bootloader starts and the main memory starts execution of the kernel. Here you may get a doubt what is meant by kernel. So kernel is the core component of the operating system. So means it's a piece of code which is responsible for managing hardware and system resources. It acts as a mediator between the physical parts and the software applications. So kernel is a piece of code. Let us suppose you are playing music. You will go to the music app and you will select a song, and whenever you hit play button, so the software will give a signal to the kernel to initialize the speakers and to read the data from the memory. So the kernel, what it will do is it will read the memory from the kernel from the memory, and it will send the data to the speaker. Next, kernel initialization. So once the kernel is loaded into in memory, it initializes every hardware devices connected to it, and it sets up the memory and launches essential system processes. This involves configuring device drivers and other low-level system components. So each and every component of the system is initialized now. After that, init or systemd. This is the first process or first code to be executed after the kernel is loaded into main memory. So this system manages the initialization of user space services and processes such as starting the graphical user interface, network services, and all the other background tasks will be started by this systemd process. After all this, so finally the user will reach to the login stage where the login screen will appear and user is asked to enter the login password. So after verifying the password, the system will comes under the control of the user. This is the boot flow of general purpose systems. So now we will see about embedded system boot flow. The boot flow of embedded system would include the following steps. First of all, power on initialization. Second step is zeroth stage bootloader, which is also called as firmware. The third stage is first stage bootloader, or it is also called as SPL, secondary program loader. Third one is bootloader. Fourth one is bootloader. Fifth one is kernel, and sixth one is applications. So same as post, which is in general purpose system, here power on initialization also performs the same task as post. All the basic functionality of the hardware is checked, and the working of the hardware is checked in this stage. So next one is zeroth stage bootloader, which is also called as firmware. So what it will do is it performs the initial configuration of all the boot peripherals. Boot peripherals means in the sense like timers, phase lock loops, and the system clocks, SRAMs, DRAMs, everything. It will initialize everything and it will configure everything. So after that, it will check for a boot media for the next stage bootloader. So this code will search the memory card or USB device which we connected as a boot device to the system. It will check for the next stage bootloader, and if it is found, the zeroth stage bootloader will load that into the SRAM and starts execution. Now the control is handed over to the bootloader, which is loaded in SRAM. So now after the zeroth stage bootloader, the control is handed over to first stage bootloader. So Many embedded systems uses U-boot as a first stage bootloader. U-boot is nothing but universal bootloader. So U-boot environment requires more memory that is available than the available memory, internal memory. So what it will do is, what the U-boot manufacturers did is, they split the U-boot into two stages, like first stage bootloader and second stage bootloader. And what the first stage bootloader will do is, it will initialize the DDR3 memory, or the memory, the RAM which is connected on the board, embedded system board. It will initialize and it will start the operation of the RAM to load the larger fully featured version of the U-boot into the RAM. And after initializing, it will load the fully featured U-boot, like the first stage bootloader will load the second stage bootloader, which is the part of U-boot, into the RAM, and it starts execution. The RAM will start execution of that U-boot. As you can see, U-boot is also known as universal bootloader, and it is also called as DAS U-boot it's an open source bootloader for most of the embedded systems. So what it will do is, so it searches for the kernel image in the boot media, and it will loads the kernel image into the main memory and hands over the kernel control to the kernel. So the boot flow, or the tasks, which is kernel, now the initialization, now the control is in the hands of kernel. The kernel initializes its core services such as memory management, task management, and interrupt handling, same as in general purpose systems. Here also kernel will take care of everything, and device drivers are loaded and initialized to manage peripheral devices. After the kernel is loaded and everything is initialized, now the application will be loaded by the kernel into the main memory. The main application means, you know that embedded systems is designed to perform or designed to execute only one application efficiently. So when compared to general purpose systems have a number of applications to be executed, but in embedded systems we have only one application to be executed continuously efficiently. So the kernel will load the main application code and it starts executing that. The main application code would be a specific control algorithm, a user interface, or any other specified function. Whatever it may be, only one application will be run by the embedded system continuously. So then after that, the system will transitions into normal operating state, so where it performs its application intended task. So the application intended task would be continuous monitoring, control data processing, or user interaction. Maybe some embedded systems would have some operating system where in that user interaction may also have. So this is about the boot flow of general purpose systems and embedded systems. Hope you got an overview about the boot flow of embedded systems and general purpose systems. Hope you like the video. If you like the video, just share the video, do a comment on the below, just subscribe the videos and subscribe my channel. Thank you.